I will now leave the floor to Emmet, which is the Managing Director of YAGMA and is also the chair of this consortium. YAGMA is a Netherlands-based research consultancy that supports responsible innovation. So I will give the floor to Emmet. Thank you everyone for being here again.
Thank you. Hello, good morning everyone, and then welcome to the final conference of the BioRadar. So today is important for all of us as a consortium to show what we have done in the past 3 years. So, but we are not only here to look at what we have done in the past 3 years, but also look at look forward for what comes later in this field. So BioRadar, of course, we look at I will go through the slides, and then you can see that we mainly looking at the building individual tools and different things. But the bigger ambitions of the project was support to kind of the more evidence-based approach in the transition in bio-based industry. So we wanted to have a simple answer to the simple questions that, okay, if a product or material or systems is it bio-based, how do you usually actually know that is going to be sustainable, circular, economically viable, and socially responsible, and also ready to wider scale? So that is what is the talk today about, and what we try in BioRadar to achieve. So I go through the slides. So we had a wonderful consortium of the 7 partners from 4 countries, 4 European countries, coordinated by us from YAGMA from Delft, as Chiara said, in Netherlands. So we made this consortium was the combination of the different types of the expertise. So research and technology organization we have university, SME, and also, as Chiara said, a standardization body on board. So this was important because the challenge that we are tackling was addressed not only scientific, not only from the regulatory point of view, but also from different angles. So it's a practical, it's a regulatory, it's market-oriented, and also societal. So from the start, we knew that the sustainability and circularity of the bio-based products cannot be in isolation, cannot be solved by one discipline alone. So that's why we have expertise in environmental assessment, circularity metrics, we have economic understanding, and also social assessment, digital tools development, and standardization and dissemination and exploitation of the projects to scale up in this field. So this is what the consortium tried to achieve, and this is a composition of the partners from in Europe. And then I go through the why BioRadar and why now. So that is the starting point of the BioRadar was very clear. Bio-based transition needs evidence, not only assumption. And then how we can do it, so we probably need to have a bunch of activities around the sustainability, circularity, economic aspects in order to get a direction towards this aim. So the bio-based, of course, is, as you know, is very important for Europe as a kind of a strategic activity. So it supports the Green Deal, it supports decarbonization, circular economy, and also reduce dependency of the fossil-based resources. But being bio-based is not automatically guarantee that we are sustainable. And that's why these biological resources that we are talking about is, of course, is renewable, but they are not unlimited. So land, water, or biomass, energy, logistics, processing, and end-of-life infrastructures all matters. And that's why bio-based products may perform well in one dimension. I mean, dimension of this dimension that I mentioned, but it maybe has some challenges in another dimension. So it may reduce the fossil carbon or increase kind of the land pressure, but at the same time increase the land pressure. So it's a kind of the maybe recyclable in theory, but actually is not in practice it works. So that is what we try to see what dimension that actually matters most in the different sectors that we work, and then what dimension we need to work on to improve it. So we create kind of the kind of value chain. So while introducing the different aspects of the environmental, social circularity. This is why BioRadar, I think, is relevant, and I think we believe as a consortium that is relevant. We need to move beyond those assumptions and provide kind of the comparable indicators, comparable tools, I mean, having tools and also evidences in order to show that, okay, how we can go towards the sustainability aspects of the bio-based products is not only the fact of the bio-base is guaranteed that we are sustainable. And that brings some challenges. So the sustainability challenges we addressed is a kind of the multi-dimension that I'm going through it through the discussion, through the slides. So it's a start from the environmental sustainability to policy. So in BioRadar we look at environmental performance, but not only, for instance, the carbon, but we also look at the different impact categories and impact aspects and issues like land use or toxicity, biodiversity, or resource depletion. So we look at also circularity, and that's the point of BioRadar. So combine different aspects and different sustainability in order to see how we can address these challenges. So we look at the circularity, which includes, in that case, material sourcing, recovery, recycling, or biological loops, and waste prevention. We also look at the economic performance to some degree. So because we thought that this economic viability and the feasibility of the bio-based products and material or value changes matters. We also look at the social aspects and social performance, including labor conditions, right, inclusion, and then community engagement, and so on. Those who are basic in social life cycle assessment that exists. And finally, we also, as Chiara said, we look at the standards and policy. Because companies don't operate in silo, so regulation, possibly certification and standardization, moving them forward, and that's why we try to look at those aspects too. So the question is, how do we move from these isolated indicators to kind of the decisions by the BioRadar or other projects? So because the aim is not only BioRadar probably look at these objectives, but other projects to have a decision that actually improve bio-based systems. And BioRadar try to answer it through the tools, evidence, and connecting these tools and evidence to users. So that brings us to what so-called BTI framework that we work. So bio-based system transition indicators is let's say, I would personally put it as a core of the project. So everything was around this core of the project's BTI framework. The purpose of BTI framework was and is to create a common structure, as mentioned about the challenges, common structure of those challenges for assessing bio-based products and systems across different sustainability and circularity aspects and dimension. And for me, the most important point was the framework is not just kind of the list of indicators, but also kind of to give a way and roadmap to organize decision making through this aspect. So it's not only looking at the like LCA in practice, but also looking at the other aspects, circularity, economic aspect, and so on. So it helps users, hopefully, we hope that it helps users to understand what they should measure at the different angles, and why this matters from the indicator perspective, from user perspective, and from the sustainability, and how different dimensions can actually relate to each other. That is what we try to to do. This is especially important because companies, as far as we know, and policymakers are often overlooked different aspects. So maybe they are quite good in environmental sustainability, but not looking proper into the social aspects or economic aspects or other way around. So the BTI framework gives kind of the shared understanding and a common understanding of the language, so to compare and monitor and kind of discuss this bio-based transition performance in a more structured way. So that was the core of all of our activity. And then that brings us to the logic, that this logic of BTI brings us to what actually we have done throughout the projects. What try to avoid, what is normally happening is kind of the fragmented view. So we try to avoid this fragmented view and make a kind of a set. So where environmental experts that we also have in consortium look at LCA, we also have a circularity experts to look at the circularity metrics and material loops. An economists also look at the cost, and a social expert look at the social aspect and social dimension and the stakeholder issues. So this transition from the fossil-based to bio-based through the lens of the bio-based transition indicator systems, that is what we try in the BioRadar to try to do. So the value of the BTI framework is more around this dimension, as you can see. And then what we have done also throughout the project, that today our colleagues from the different angles will comes and then explain more about the tools and then or evidences that we achieved. But in general is a kind of the value is it together, but it's not, doesn't pretend to a kind of the one single aspect is more important than others. So instead, it helps kind of to users to see a trade-off between different aspects and then find the hotspots and improvement area across the field to be able to enable decision makers to have reach to the decision points. This is very important for the future of the bio-based products and bioeconomy in general. So, because the next stage will not only about developing the new materials, but it's also about demonstrating these materials that can be in more sustainable and circular way. And then we reach to the kind of our project objectives and the area of the work. So BioRadar has been demonstrated in bio-based textile, packaging, and chemical. Of course, as a project of 3 years, we could not go for all the sectors. So these 3 sectors has been selected because they represent different aspects and different type of bio-based challenges. In textile, question of fiber sourcing and processing, durability, and recycling and social risk are matters and was central for us. And packaging, the challenge that closely linked to material choice and recyclability and regulation and end of life. And in fertilizer, through partners that active in the projects, the circularity aspect and logic was central for us to at the different aspects. Of course, we look at the environmental aspects and other things, but circularity, because we are dealing with the soils effects and mineral, fertilizer, and so on. So across all of these 3 sectors, we also improved metrics and framework for assessing environmental impact and also circularity, economic performance, and social implication. So we also develop tools, and we go through these 2 tools throughout this presentation a little bit as a kind of just list them, and then tools going to be features during today's presentation. We also try to see how we can upscale opportunities and standardization needs. So the sectors not only for us was a case study, but also the learning cases for the future activities and wider impact that basically we can do. How we approach this, so it's I try to basically it's difficult to say, okay, after 3 years how we have done it, but then what I could see is that once we do it, it's more at the kind of the system perspective. So we did not only look at the product in isolation, but we also look at the whole process. We look across the value chain and try to improve it, and then if reflected to the tools and results that appear. Maybe we don't call it during the project as a system perspective, but one can see that is actually what we have done is more from the system perspective. So it's a kind of from the feedstock to end of life and policy and use and circularity. This matters for us because many sustainability impact don't appear at the product level, because we look at the product level, of course, in center, product performance and LCA and so on, but we also try to look at more in the more systemic view, so to more have kind of the transition intelligence as much as possible, as much as we could in 3 years project. So the aim is not only to whether the product is better than another one, so if the bio-based is better than fossil-based, but also understand where impacts occur, which is through the impact categories of the sustainability aspect, environmental sustainability aspects, or circularity opportunities, where the circularity opportunities exist, where decisions and improve can come. So this is where the project basically stands. And then how we have done it, as I said, in the 3 sectors, fertilizer, packaging, and textile, was the test area for us to whether a common assessment framework, or the BTI framework, as I mentioned, is possible across this one or not. Of course, it's not like other activities and other projects. We are not succeeded fully, and saying that, okay, all of these 3 sectors, we dig into it very in detail. But for fertilizer, we look at the aspects and the circularity and sustainability through the nutrient recovery and soil, also the mineral fertilizer, and then for textile, for instance, in the products that has chosen in the project is more in the terms of the fiber sourcing and treatment process and so on. So what we have done is kind of try to match this BTI framework, as I mentioned, bio-based transition indicators framework, how that can help the sustainability and circularity performance of the product in terms of the bio-based activities. So that is what we try to do in the project, and that is the tools and decisions comes, which I think each of them, I mean, BTI framework, yeah, each of them probably has a slot today. To talk about the assessment framework, assessment platform, regulatory tracker, a standardization toolkit, implementation scorecard and replication facility, and BTI framework, which is I mentioned. So it provides a common kind of the indicator logic, like insider, what we have done in these 3 years. As you can see, is partly digitalized, so digital tools. The first BTI framework is framework, but the assessment platform and the regulatory tracker was those digital tools. So for assessment platform, support kind of the self-assessment, AI benchmarking and analytics for the products that basically where they are standing. Regulatory tracker / policy tracker tool follow kind of the policy and regulatory development and searching engine for that. And then a standardization toolkit is going to be support alignment of the standards. And then we have the replication facility as a whole and MOOC, massive online courses, and implementation scorecard that helps hopefully SMEs and companies to better understand where they are standing in terms of the sustainable development goals and their improvement and how mature they are, basically. And then it depends on the maturity they have. We shift them to assessment platform, a standardization toolkit, or regulatory tracker, what they need to do. So we create a kind of in general, kind of the decision support systems or decision support ecosystem to help them to users to have these better questions about how they can compare their bio-based products against their other products and identify improvement for even bio-based products. So that is, I think each of the slides, as I said, is going to be discussed more. So I just pass on for the part of exploitation. Of course, exploitation is one of the things all of the, not only EU project, any activity they would like to exploit. So they would like to have a reach to the market and uptake activities, which is challenging, especially for, I think, European project of 3 years is challenging because you reach to the point of development of the tools activity towards the end, and then now you need to exploit, which, yeah, it's possible, but you need a bit more time, but you don't have more time. So that is the different than like at a company setting. So because you think about exploitation, actually exploitation brings you to develop the tool, and then you develop the tool and exploit it. But this way is a little different. But anyway, so different users need the different use of the tool or activities. And that is the similar for us and companies and SMEs. I think companies can, in our view, can use the tools and indicators to understand their sustainability and circularity performance, identify gaps, and prepare for even for reporting if they need, or in very higher cases, market positioning themselves in terms of the bio-based activities. And SMEs, as I said, for instance, innovation scorecard we have, and self-assessment logic to start with the from that lens to see where they are standing and then how they can actually work with the larger corporation. The policymakers then can use the BTI framework to understand where support, regulation, and incentives may be needed. And also, we put the investors, we have not go through it, but potentially we believe that the funders and investors also can use the result to understand whether bio-based solution actually is not only innovative, but also that can be used as a transition-ready phase. And also, of course, a standardization organization that can get the knowledge from our activity to support the future standardization and pre-standardization activities. And last but not least, of course, researchers and future projects can also reuse the framework, methods, tools, and database that we have to expand their activities and not do the same things that we have done it again. So it's kind of hopefully BioRadar creates a value when it's different actors comes to it, and then for different actors we have a different aspects. So towards the end, I want to highlight beyond what it comes beyond the project, what is a replication and capacity building. This is why today not only seen as a kind of the only closing events, but also it should be kind of the handover moment for us. So we're handling over the framework, a set of tools, a knowledge base that we have, and also a way of thinking about the bio-based transition. And that is what we try to use it, test it, train it, align it, and scale. Not only us, we can do it, but the rest can also do it. So use the tools and indicators that we already have. New indicators actually appeared, especially under the circularity, for companies and projects can use it. And then, of course, the second is the testing of what we have. So testing the tools and everything, the BTI in more other products, because of course due to limitation of the time we use it. We have not all the products, so it can be tested in more products, more sectors, and more regional contexts. And also the third one is can be training of the people through the massive the online course that we have and replication facility, and then we can align the result and the standards and policy and regulation and reporting if there is any. Then we can of course think about collectively about the scaling of the new bio-based value chain. So this is what we could see that not only others, but also us, we can use it for later moment. Then, yeah, okay, I should have done it. I forgot. So that was the 2 click. So that is the use, and then the test and train, align, and scale. And then last but not least, so to conclude, so it's BioRadar, as I said, is more than a set of the achievement or set of deliverables, of course. So we hope that it's not the deliverables, only deliverables. So it's kind of the contribution to providing evidence for evidence-based for bio-based systems. And important because the bioeconomy not only needs the deliverables, of course, it needs innovation, but also need the kind of trusting to the different aspects. And we hope that BioRadar sets, including activities we have under sustainability, circularity, that can help the organization to go forward. So that is by that. I would like to thank you to hear about our project, and also I would like to thank all the project partners, BioRadar partners, for this wonderful 3 years. And then also commitment, very nice project and activities that we have done today. And then hopefully we can have demonstrate what we have done in other projects or other activities together. Yeah, thank you very much. Yeah.
I invite the next presenters to come on stage. We actually have 2 presenters for this next presentation, but one of them will be joining us online. And thank you so much again, Emad. And I feel like just as companies can have a fragmented view of their sustainability pathways and tools, then we can also have a bit of a fragmented view of what we have done in these 3 years. We have done a lot was achieved, but then it's very easy to focus on the moment and on the task that we have in front of us and not enjoy what has been done in these 3 years. So it is really great to be here to present the project, but also for us to see in a bird's eye view what we have done in these 3 years. So it's very nice to see it all coming together. Are we ready? Yeah. Our next presentation is about the Bio-Based Transition Indicator Framework, so the BTI Framework. I will not go more into detail about the BTI Framework because Emad explained it quite well, and then Matteo and Hassler will give more details on that. We have here in person Matteo from NTT, which is a research center in Tuscany, which is focused on innovative and bio-based textile materials, and they work on improving technological innovation and the competitiveness of companies. As we said before, as Emad said before, we have three focus for our sector. So we have the packaging, the fertilizers, and the textile sector. So NTT is here to also represent the textile sector. And then online we have Hassel Iglesias, which is from Setemma, which is a company based in Cartagena, Spain. They are technological partners for companies that are committed to improving their sustainability, efficiency, and innovation. And they add value by offering advanced technological solutions which are adapted to the sustainability challenges that we have that are ever evolving, both in the energy transition and the circular economy sector. So I will leave the floor to Matteo first.
Yep. Yes. Yeah, thank you. Thank you so much. I have the control. Okay.
The good part of the European projects is that we have partners from multiple countries, so we can go and visit them. So it is actually the first time that we are here in Milan, and we're very happy to host them.
Okay, so good morning to everyone. Thank you to be here and online. I will talk about a part of the BTI framework, that is the evaluation, the assessment of the sustainability. and we choose this very simple name for this part. So, as said by Emad, we evaluate products from 3 sectors, so textile, packaging, and fertilizer. And these are the products that we evaluate. So, wool, hemp, PLAs, lyocell, and viscose for the textile. There are the list for packaging, and also compost, feather meal, and wood vinegar, and alga-based fertilizer for the fertilizer part. We applied a 3 pillars framework using different methodology to evaluate environmental sustainability, so life cycle assessment, indirect land use change, and energy. We evaluate also the society, so the social sustainability, and we use 2 different approach, so a bottom-up and top-down approach using surveys and also a dedicated database for the assessment of social hotspot. And for the economic part, we apply the environmental life cycle costing and also the eco cost. I will explain a little bit which are these methodology. So LCA, probably you know, is a standardized methodology that quantify the environmental impact of products and processes during the entire life cycle. Energy is a quite not very known methodology, but very interesting, in particular for the bio-based product, like in this case, is a methodology that is able to evaluate the total energy expressed in a particular unit, that is the solar energy equivalent, that are required directly or indirectly to obtain processes, services, and so on. The indirect land use change is a methodology that evaluates the unintended land conversion. So when we have to, we want, for example, for bio-based products, we obtain material from the nature, but probably we will have to replace land occupied for food to produce something that we need for, I don't know, for textile, packaging, and so on. Voice? No. And, okay. For social evaluation, for the social assessment, so we evaluate, as I said, the social and socio-economic aspects, and also the impact along the life cycle of these products, with 2 approaches. So for we collected direct information from companies and from workers with the use of surveys, but also we try to understand the impact of the supply chain of these products based on the use of a social hotspot database. That is a specific database for social LCA in the CIMAPRO software. And then we also evaluate, as I said, life cycle costing that estimates the total cost, the direct cost of a product, and also the eco cost, that is a methodology that is able to assess, to say it as the indirect cost of environmental impacts. So a big part of our work was first of all to find the right methodology to try to describe the impact and also the impact of our the products that we selected. And we also try to create a framework able to reduce the data needed, in order also, because our idea is also to have this framework for in the future for companies. So companies usually they don't have a lot of time, so they don't want to less time and also money. So they want to reduce. We try to reduce the data that we need. So we started as usually for an LCA with the collection of all the input-output data involved in the process. Then we use some specific emission factor that are present in the LCA software. So in our case, CIMAPRO and Sfera. For the image evaluation, we use again the data that we collected for the LCA, and we add some specific unit image value that are conversion factor for this methodology. The input data are also useful for the indirect land use change, and then we use also a specific emission factor created by the European Commission. Then the results from the LCA was useful for the evaluation of the eco-cost, because are the base for the evaluation of the eco-cost, and we add some external costs from the literature. Then again, we started from the input-output data from the LCA, and we add some unit price for the assessment of the LCC. And then part of the data from the LCC and part of the data from the LCA was useful for the evaluation of the social aspect based on the social hotspot database. So thanks to this framework, we evaluate with a reduced number of data the three assessments. So I will show you some very short, very quick results. There will be one slide for each assessment. On the right, you will see aggregated results for the three sectors, and on the left, there is a focus regarding the textile, and sometimes, in this case, also a focus for the wool. So I didn't report all the results because are a lot of information. So what we find, what we understand in these 3 years through the application of this methodology. So regarding the environmental sustainability, we saw a very important fact, that is the triangulation of these that we applied with the use of these different methodology are able to prevent blind spots. So we try to use methodology that talk together in order to have a better vision and also a huge vision respect the application of, for example, only the LCA. And okay, probably is not new, but biobase is not automatically sustainable. So it's very important because the sustainability of these products are very related to the, for example, the energy mix, the process chemicals that are used during the process. Also very important is the land use, and also the end-of-life design, because we saw that if, for example, I don't remember if I put here this information. Yeah, for the e-look, we saw, for example, that it should be very important to valorize the residual, for example, for the fertilizer. In that case, the impact are lower respect other type of fertilizer, for example, the fossil one, or also other type of bio-based fertilizer. And okay, there are some main important hotspots. So, for example, the electricity, the heat demand, but also, as I said, it's very important to optimize or replace, in some case, some critical chemicals, and valorize the co-production that we can have in some type of process like this one. Okay, and then the energy also help us in order to understand the real effort of the environment, because this methodology is able to have a larger vision, so have larger boundaries respect the traditional methodology, so we can have a more clear vision on which parts of the impact are related, are free for us. So because we consume some resources from nature. Regarding social sustainability, on the in the upper part of the left, you can see the percentage of the answer that we receive from the application of the survey. So where is located the people that answer to our survey, and also some of the main social evidence. Again, that is the focus for the textile. What we understand in our evaluation, so we found some positive results. So we saw that, for example, that decent work is largely ensured obviously in the country that we evaluate. So from where we obtain answer. So there are very high percentage of positive answer, for example, for the formal contracts, permanent jobs, social benefits, but also safety training, the provision of PPE, and so on. And then, okay, regarding, there are some gaps in social policies and also for workers. So, for example, there are a lot of people that answer that say that are unpaid overtime, so more than 60%. Around 30% said that they have an insufficient wages, and also the limitation of health assistance. And there are also a week of working engagement in the companies, and for example, also a limited gender equality plans. That's a little bit higher because 40% of answers said this. Another point interesting is that there is not a real transparency for what is regarding, for example, the sustainability reporting, because few companies has a sustainability report, but they said they declared that they have in compliance with the ESG, but they don't have a real evaluation of this. And regarding the economic aspect, economic assessment, we saw, for example, that costs are very sector specific and also depending on the energy and labor. For sure, the economic part are very connected, for example, with market price and volatility. So respect an environmental evaluation that is, we can evaluate now or tomorrow, that could be a little bit the same. For the economic part is very sensitive for on this aspect. And also we saw that are sensitive for regarding to the design of the system. So for example, we saw for the compost is more cost effective when the biogas valorization offsets with the valorization of offset costs, sorry. And for example, the algae fertilizer are very dependent, for sure, on the cost of the wastewater that they use for cultivation of the algae. So, in conclusion, some takeaways from our assessment. We saw that there are no single solution that fits for all. Because because it's very dependent, the results, on, for example, the energy mix, as I said, the type of chemicals and the quantity of chemicals that you use, and also the type of land used to apply it. So it's very important to evaluate the sustainability case by case, because, for example, what we evaluate for our products are not for sure valid also for a similar products, but we have to evaluate the specific case. Okay, some other important things for example, that we saw, as I said, that it's very important the integration of this assessment. So we demonstrate that this integration works. So the combination of this free methodology for the environment, to methodology to approach for the social, and to methodology for the economic part are very, very important, because we can have a more clear, a more valid, a more realistic vision of the processes and of the impact. And to conclude, okay, for the future, we would like to improve this type of framework. So should be very important to talk better and more, for example, from the two aspects of the sustainability assessment and the circularity, because they are very connected. So we could improve in that direction. Could be important to develop tool for suppliers, for companies, for research. So have a real application of a framework like this, and also things that I didn't put here, but it's very important to enlarge the quantity of data, so the involvement, for example, of companies, more direct data from companies, in order to have more quantitative and qualitative data for future implementation. So, thank you very much. And I leave the floor to Asler.
Yeah, hello. I don't know if you already see me and hear me. Yeah.
Yes, we can see.
Okay. Well, obviously I'm sad for not being there with you all, but in any case, we can share these results through this platform. So I imagine you are already seeing these slides, just the first one of them. So I'm going to talk about the circularity part of the BTI framework, which was based on basically three main steps. First, figuring out how people and companies and institutions were already measuring the circularity of bio-based products in these three sectors. Then, based on what's being already done, developing new circularity or propose or improving this already existing indicator base, and then validating this with either with data or with companies. We're going to dig a little bit on that. So first of all, we started with a systematic literature review that, as I said, we looked for bio-based circularity indicators for fertilizers, packaging, and textiles in scientific databases. From there, we found over 160 articles that talked about 88 indicators. And we combined this academic database with, let's say, industry or policy documents, including ISO, the European Commission, leading organizations such as the Ellen MacArthur Foundation or the World Business Council for Sustainable Development. From there, we found 16 documents and 35 indicators that at the end, we compiled 123 indicators that were already under use for these kind of products we are focusing. So what did we find? We find that most of the documents, as you can see in the left-hand side, most of the documents were focusing on packaging. So packaging is being the one that accumulates more documents, followed by fertilizers. And also we found that many of these documents were relying on well-established indicators. So the majority of the studies were focusing on LCA, as you can see in the right-hand side, like a huge majority of the studies assessing circularity were using LCA, followed by the material circularity indicator of the Ellen MacArthur Foundation. So this led us to a reflection that actually the results of an LCA does not tell you if a product is truly circular. It tells you about the amount of environmental impact on different issues, on the atmosphere, on water bodies, on the soil, on the land use, and so on and so forth. But per se, it doesn't let you know if a product is circular or not. So we developed this kind of diagram where you can see, well, life cycle thinking, understood as an entire knowledge area, is embedded into environmental sciences. And it focuses on material use, the energy, the consumption. It uses life cycle inventories, measures the global warming or the ozone depletion, and so on. It also has a connection with economics, like conventional economics, where you have to look at costs, revenues, demand, supply, the profit, the return on investment, the cost-benefit ratio, the famous EBITDA. So obviously, when you are developing a product, you have to look at these two sides. How, if it is profitable, if it's economically feasible, and how much I'm damaging the environment or even improving the environment. But then circular economy is kind of a middle point. It needs, obviously, from its name, it needs economics information, but it also needs environmental information. But it looks, I mean, its focus is on the famous 9 R's. If the product is refusing, rethinking, reducing, reusing, and so on and so forth. So an LCA may help to assess the circularity of a product, but it doesn't have the final say whether a product is circular or not. So this is, it may seem obvious once someone explains it, but in reality, in all these documents, they were assessing circular economy, most of them directly applying LCA. And so we believe that they were not reaching any conclusion about true circularity, but rather about environmental sustainability. So then we saw the indicators, and in the left hand, you can see the distribution. In the scientific literature, it was kind of balanced. Most of them were general. General, it means it can be applied to any kind of product, to electronics, to cleaning materials, to health supplies, and so on. And then fertilizers, packaging, and textiles. And in gray literature, these policies and standards and so on, they were all of them general. I mean, they are not specifically developed for neither bio-based or a specific sector. They are applicable to any kind of products. So this is a main difference between what academia is doing and what the industry and the policy sector is doing. Then when looking about what is being measured when someone says, okay, I'm going to carry out a circularity assessment. Most of the indicators in the scientific literature measure the efficiency and the input of recycled or reused materials. So they are really focused on if I'm producing something with a recycled material and how efficient am I in doing that. On the other hand, the policies and industry documents also measure efficiency, but have a more balanced approach, including the ability of the final product to be recyclable. They include also the environmental impacts, also look at how the end-of-life processes are managed, whether the product is going to be released in a dump or being burned in a thermal retrieval installation, and so on and so forth. So there are indeed some differences between what, again, the research sector is doing and what industries and policies and policymakers are doing. So you can look at this in a more detailed approach in an article we have got released a few days ago. It's open access, and you can have a look at that if you are interested in more detail. Then For the development of the circularity monitoring framework, we use the design research method. Basically, it has 4 steps. First one is the research clarification, which was done through the systematic literature review I have just explained. Then a descriptive study, which, well, we took all these indicators and we assessed them. We said, okay, they have this strength, they have these weaknesses, so we characterized them. Then we made a prescription, okay, based on this situation, based on this diagnosis, we propose this set of indicators, and then a second descriptive study. In this case, we describe the use of these complete set of indicators we proposed. So the result of all this process was these 8 indicators. As you can see, we have 2 for general use and then 2 for each sector. And also in each column, you have 1, which is a currently used indicator stemming from the review, either from scientific literature or from business and policy documents. And we complemented it with a new indicator. The new indicators are not intended to be the best indicators of all. They are just intended to cover the gap of the existing one. For example, the circular index, which is under the circularity methodology developed by the energy company Enel. It's a pretty good, I must say, but it missed the biodegradable part of the product. So it missed all the biological loop. So we said, okay, we have a pretty good indicator, but we have to complement it because we're working on bio-based with the biodegradable content of the product. So this is the case for all the other. Perhaps just to mention a little bit, the circularity indicator of nutrient is focused on the efficiency. I mean, how efficient is the process, the manufacturing process, to recover nutrients from a waste stream? I mean, how much of the nitrogen, let's say, in a waste stream is kept in the final fertilizer? We complemented it with what happened when you apply this fertilizer to the soil. Are the nutrients released fast and in most cases causing eutrophication, or are they released slowly and supporting more the plant growth and preventing eutrophication? There is also, I think, a problem, an issue with the availability of these data and how easy they can be sourced. Then in textiles, the resource pressure, I'm going to talk about a little bit later about it. And we complemented it with the fiber treatment circularity index because we found, okay, the current indicators, they were very good at measuring how the fiber are produced. But the truth is, most fibers need further processing before becoming textile products, end-use products. And in this post-treatment of the fibers, lots of non-circular or non-bio-based products or supplies are used. So we put the focus on there, like measuring how circular are these inputs that are being used in the post-treatment. And then packaging, a similar situation. Even, for example, talking about cardboard, if you recycle cardboard, you have to include some non-circular material. You cannot produce cardboard out of 100% recycled cardboard. So we put the lens on that. How much virgin material is used within recycling processes? Again, these results are also available at an open access article, which was published a couple of months ago in the Journal of Sustainability. So you can scan the QR now, or just look at it afterwards. Then we validated this set of 8 indicators. For the fertilizer case, it was used based on the LCA results our colleagues Mateo and David produced, and also using LCA results from other European funded projects. So here you can see how useful the circular index, for example, is to compare different fertilizers, comparing, for example, compost with algae. Also, the biodegradable content helps to highlight, I mean, for example, algae is 100% biodegradable, but the spent mushroom substrate includes certain inputs that are not per se biodegradable, although they are inert, they are harmless to the environment, they are not biodegradable. So it can help you identify these kind of subtleties. The nutrient release index, again, we only had data for these 2. And the circularity indicator of nutrient, again, you have algae with 100% of algae all its nitrogen is then applied on soil. But for example, wood vinegar that stems from burning wood, the process loses lots of the nutrient. So regarding circularity, nutrient circularity, well, wood vinegar is the least circular of all. Again, you can find this in another published article, open access, the validation of fertilizers. Then for textiles, we talk about resource pressure. This is a really interesting indicator. It's already existing one that compares the impacts of a product on the planetary boundaries. Is this concept as we have, the planet has physical and environmental boundaries that we must not trespass in order to be sustainable. So this compares that. And perhaps the main application of this indicator and the validation we did was comparing 3 bio-based fibers, namely cotton, wool, and hemp, against non-bio-based, which is polyester. And we found that in this case, actually wool, hemp, and polyester regarding planetary boundaries are pretty much equivalent, but cotton really exerts a higher pressure on the planetary boundaries regarding this case. This is a waiting publication, so I invite you all to join us, crossing our fingers to have it published soon. In any case, it's available in the deliverables of the project. And finally, for packaging, we conducted a real case with a Spanish manufacturing company that produces cardboard and paper. And here you can see how we were able to compare the company's products with the general average, namely all the BioRadar products assessed, and against the packaging average. Also, this company had some uncertainty regarding the efficiency of a specific process. So they told us, they were uncertain whether they could reduce their waste to 5% or to 15%, and they wanted to know if it was worth it to invest in improving this process. So these indicators are also applicable in guiding or leading these investment and managerial decisions, whether to improve or not a process is worth it in terms of how much it's going to improve the circularity. And I think that's all I have from my part, and happy to answer any question if there is any.
Okay, thank you both, Hastler and Matteo. Round of applause. Now we have another session before our lunch break, and then we go from the BTI framework and the more conceptual level to a more practical implementation of the tools that have come from the BioRadar project. We will explore in this session the BioRadar toolbox, which has already been given an overview of before, but then we will look more into detail each and every one of these tools in the toolbox. There are a set of digital tools, and they are designed to support the goal of BioRadar and the monitoring, evaluation, and improvement of sustainability and circularity performance. Each tool addresses a specific dimension. We have data-driven assessment and benchmarking, regulatory tracking, standardization and implementation monitoring, and taken together, they form an integrated system that enables users to navigate complexity and turn data into actionable insights. As we said before, the BTI framework gives, as the name says, the framework, and then each of these tools is quite important in itself, but then when they all come together is really when they have the maximum exploitable results. We focus not only on innovation, but also on usability. We ensure that this tool can be effectively adopted by companies, researchers, policymakers, whoever is working in the bio-based sector and strives to have a higher degree of sustainability in one or more of the aspects. Now I will give a general introduction of the toolbox. The first speakers that we have are Poojan and Davis from IRIS, which is Europe's leading company in the production of photonics and artificial intelligence solution for the real-time control of industrial and production processes. They will explain and talk a little bit more in depth about the sustainability assessment and the BioRadar assessment platform.
Thanks, Chiara. Good morning, everybody. My name is Puzanti Milsina. I'm an innovation and project manager at Iris Engineering. We're a small SME based in Barcelona. And today I'm here with my colleague, AI expert David Netherland. David, if you want to say something.
Hello, good morning.
Okay, so Iris is an engineering company based in Barcelona, and then we do quality control. So before starting my presentation, I'd like to do a small quality check. So basically, the partner, I could see your other partners here, but then our colleagues who are in the backmost part of the meeting hall. Quick quality check. My colleagues have been presenting BIORADAR project. Can you just tell me what are the sectors that we use in BIORADAR? So we have been explaining what we did with all the indexes. I'm just doing quality check to see if you guys are listening to us. Okay, no worries, guys. Don't hate me also for this. So we are focused on 3 use cases, okay? Fertilizer, textile, and packaging. And today what I'm going to do is within all the investigation and research activities my colleagues, they did through the BIORADAR project, we prepared a digital tool, an assessment tool, where you could generate data and where you could compare data, your data, but also project-generated data, okay? And then the focus of this digital platform was first to complete what we have contractually explained in BIORADAR contractual agreement, but also to provide a solution to industries and also to academic partners who are working with LCAs, and we are working with several assessments, okay? So I'm just gonna quickly log in. You can see my screen, right? Online guys also can see my screen. Perfect. So for those who have never entered to this BIORADAR assessment platform, you get this is the first landing page where we explain quickly what are each of the sectors and what are each of the modules, what is the self-assessment tool, what is synthetic data, what are each of the sections that you see in the uppermost menu, which is we have file repository, BIORADAR assessment platform results, synthetic data, and self-assessment tool. So the first 2 options, file repository and BIORADAR assessment platform results. File repository, basically, and also we have this functionality, which is a wizard. So whenever you go through the assessment tool, it's going to explain you each of the modules, so that the user is aware of what they could do and what they can do within the platform, okay? In order not to show this again, because I have seen this platform tons and tons of time, so I'm just going to click to don't show this again. So the file repository here, you could upload your own file. I'm going to explain you why this section is useful. But then let me go to BIORADAR assessment results, where my colleagues have been explaining the LCA, eco-cost, social LCA, and circularity. You could just view the data that has been produced by my colleagues within the project and that are integrated here, okay? So for LCA, there were 16 impact indicators that were chosen by our colleagues. And then we have several use cases. So for fertilizer sector, we have algae, compost, feeder meal, and wood vinegar. But then you could check also the data for textile. So for textile, our use cases that we have used is bio-based fiber, fossil-based fiber, and so on, other 5 use cases. And also for packaging, we have used cardboard, composite, and paper. My colleagues, they already explained the background of the companies and how we receive the data. But then now we are going to actually see the data and analyze the data, okay? So for example, for packaging, cardboard, you could see the impact category that has been chosen, and then the values, okay? So this is only for LCA, but then if you are interested to see the eco-cost value or social LCA, then just select the option social LCA. As I told, and a reminder, this is just to visualize the data, but then later on you could do something with the data, and I'm going to show you later on. Okay, so for social LCA, algae, and then you have impact categories like labor rights and decent work, subcategories. Everything was done and investigated under the project, and then you have several cases, and then you could see this value here. Also for textiles, so for example, textile social LCA, let's select natural plant fiber. And these are the impact categories, subcategories, and for the hemp, what are the value for the respective categories, okay? So on for circularity indexes, and so on for eco-cost. Not going to go in detail. I will leave this part to you so that after this demonstration, you could just go in the platform and then see the value. And then now it comes the part where you can actually do something. So let's say you may be industrial partner, maybe you are working on textile sector. And one of the major, let's say, bottleneck that we saw during the preparation of the proposal and also during the execution of the project is the lack of data. So a lot of time you would like to do some analysis. Maybe you are creating a new product, but then you don't have actually enough information about what this could be, let's say, considered as bio-based or not bio-based, or if you would like to see the LCA data, but then you lack data because you don't have reference data. So in that case, I'm saying a lot of data, because the synthetic data generator section, it provides you synthetic data, a lot of data that's really similar to your cases. Okay, so now let me give you an example just first how you could compare our project's data, and then later on use this project generated data to create your own data and make the analysis by yourself. Okay, which is the part of self-assessment tool. The self-assessment tool is basically it compares, and then you also can make comparison between your previous historical data and own data. But at first, let's say you are a company from textile background, and then you are just creating a new product which is similar to, let's say, recycled wool. So at first, within the self-assessment tool, what you could do is you could compare. So you could, let's say, you could just select all the options that we have. These are the cases that we produce under our project, and then just select the option benchmarking. It shows you, by default, it shows the first case that you have chosen. And then what it's doing is comparing the general score. So we are using statistics to generate the final score using all of these impact indicators. That one of the theoretical basis that we did in BIORADAR. And then let's say, so now your product is recycled wool. Let's say the product that you are going to develop is pretty similar to recycled wool. So what you can do is, okay, so let me check my check this reference use case, which is recycled wool, and apparently comparing with the project generated data, it follows on the general marking is 8th out of 9th position. So let's say is the 8th base, or let's say the second worst, but still you say, okay, this is my reference case. Okay, and then now comparing to this case, you would like to produce additional data so that you could make further analysis. I don't know if I'm explaining. If you feel free to interrupt. Okay, so what you can do is okay, so you can see that, okay, you have chosen recycled wool as your reference case, and you say, okay, I would like to produce data, tons of data, so that I could do analysis similar to the recycled wool. So what you could do, you could just go to the synthetic data set and choose the option analyze with platform use cases. And you always need to go through the sector. For example, if you go to fertilizer, you won't see those cases. So you go to textile, and then you choose, okay, so my reference case is recycled wool. And then the platform, so one of the statistics that we use behind the generation of synthetic data is you need to you need to at least give 4 use cases for a reference. Okay, so just selecting one use case is not valid. So one option is you could choose all the 4 use cases, let's say 2 from here, and generate synthetic data. But another option is what you could do is, okay, let me take the platform's use case, which is the natural protein fiber, recycled wool, is one of the reference case, but then I would like to upload my own data, so that it takes the platform data plus my own company's data, whichever, any historical data or whatever, and then generate the synthetic data. Okay, so in that case, so this is the section where the file, so you upload the file, and then you have your file uploaded here. So you choose one of the uploaded document. In this case, I'm going to choose the textile case 2, and then you could generate the synthetic data here, over here. Okay. Okay, and then it gives you a pop-up of what is the best iteration. Also, some of the functionalities is how many observations, so how many data you'd like to download, how many synthetic data. So by default is 1,000, but then you could put 100, and how many simulations. So more the simulations, it triggers more time, it takes more time, but then it's still it's more accurate. So you could put 10 simulations and also generate additional synthetic data. It's automatically downloaded. Download has started, and then it automatically downloads and saves in your download file. Okay, So that's about the generation of synthetic data. What also you could do is generate synthetic data by using your own files. So you could say, okay, analyze with some of your own files. So you just forget about, you don't care about BioRadar project, but then you would like to generate tons of data by using your own file. So in that sense, so you say, okay, file repository, also you need to upload the same files, and then select each of the one to generate synthetic data. Okay. I'm going really fast, but then if you go through there, we have the wizard functionality, and then you will see how it is done. And if you have any queries or doubts, just feel free to text me or send me an email. Okay. Now let's go to the main functionality, which is the self-assessment. Before, we have been comparing our project's data. Now let's say you want to compare your own previous historical data with new data. In that case, you have this option, which is analyze with some of your files. Still, you always need to go to the sector that you have chosen and then choose the file. Or also you have another functionality, which is you can upload one of your previous Excel file, but then you could also use some form data. So in that case, I'm going to use one of these, okay, self-assessment, and I'll use some of your files, textile. So I'm going to select one of these, and then I'll say, okay, benchmarking, let me compare. So this is, let's say this is the file that you have uploaded. And then what it does is compares the data, well, for each of your use cases. And in that case, so now besides of the comparing functionality, what one of the AI aspect that we have included is you can not only you could compare your general score, but then you could compare your individual scores. So for example, climate change for one of the selected use case. Let's say you select randomly this one. Okay, so it appears in if you were before in comparison of results, your selected use case, this one is on 5th position. But then if you are comparing individual indicators, so maybe for this indicator, actually for acidification, it appears in the 5th position, but you choose land use 5th, but let's say climate change, and then it changes. Okay, so depending on, so it's not only the global score, but then individual indicators also could be compared. And then we have, and then if you would like to download this, let's say this information is really useful and you'd like to download, then you could just click and download it, and it automatically downloads the Excel file. And then we have another functionality, which is clustering. So clustering is, so what we have done is, if you have a lot of use cases and you'd like to see which of these are more related, or let's say which can you cluster, which are focused in, they have one sort of data and they have another sort of data, like grouping, then you could use the functionality of clustering. In order to explain the background, David, if you'd like to say something for clustering.
Well, this is just like a standard k-means clustering, but it's very efficient and it gives reliable results. Of course, as with any clustering, you need sufficient data, and so it gives you a quality measure at the top. This is 100%. It's created 3 clusters, which is the optimum number of clusters. But you always have to take into account that the quality of the data you give to the clustering results in also the quality of the clustering. Yeah, that's as always in statistics. You can analyze the groupings in this 2D space, which are the principal components of the impact factors. And you can see that, for example, here we have 3 clusters. On the left, we have the red cluster, and then we have the, can you just lift it up a little bit? Yep. And then we have cluster 1, and we have cluster 2, which is down on the bottom right, if you can see it, the green one. And so they're very well differentiated in this 2D space. The idea is that the distance between the clusters is maximized, yeah, so they're well distinguished, they're differentiated. And here, using like a machine learning pipeline, we then connect the clustering to a decision tree. And here a decision tree is what is called supervised learning, and it requires a label in order to train the algorithm. And here we didn't have any predefined labels, so we use the clustering ID as the label. And this is quite a nice trick, which enables you to build models from data where there's no a priori clear categorization. Yeah. And so here we see, if you can just open on the bottom right, click on the arrow on the bottom, on the particle matter node. Yeah. Okay. Now it opens the clusters. And so this is a representation of the clustering, but as a decision tree. And so we can see that we've got the three clusters, the green, the blue, and the red one. And also the decision, which starts at the top node, eutrophication terrestrial, less than or equal to minus 0.424. If that is true, it drops down to the left, which is cluster 2. If it's false, it drops down to the right, and then it checks particulate matter, less than or equal to 0. If that's true, it drops down to cluster 1. If it's false, it drops down to cluster 0. And this is not arbitrary assignments of the impact factors. It uses a sophisticated algorithm which is based on information theory, signal to noise ratio, to choose which of the impact factors to include. It's included just 2 of the 16. So those are the ones with the highest information value. And then it also calculates the threshold for each of those impact factors in order to create the decisions, the branches of the decision tree. So it's really quite a cool algorithm. But again, it needs quality data. If you give it bad data, then of course the result will not be good. So we always need to double check the quality of the result. And if it's not good enough, then we need to revise the data in order to improve the decision tree accuracy.
Thanks, David. So this is a good way to sectorize your data and then see what sort of use cases are more related, what are unrelated, and by this way you could make a general analysis. Okay, that's guys, that's more or less the BIORADAR assessment platform. I see that I have already taken way more time than I was supposed to. I apologize for that. So if you have any questions, queries, please just feel free to ask right now. Okay, just I'm showing my profile so that if you are, let's say, you don't want to ask any question right now, but then if you want to have other queries, as you see, the synthetic data and self-assessment tool right now only analyzes the LCA part, but then in future maybe it analyzes the social LCA, circularity, and then if you are interested to use the platform or whatever, you have any queries, just you can use my email and then just send me an email. Okay, thanks.
Thank you, Poojan and David. As a layperson who doesn't understand anything about synthetic data and clustering, I can attest that the platform is quite user-friendly. I still understood how to use it and where to find all of the information and how to upload the data. So it is a great tool to use. Next up, we have Emad again. I've already introduced him. As I said, it is the chair of this project and is representing IAGMA. Emad will tell us about the regulatory and standard tracker tools, in particular the regulatory tracker tool, which monitors the developments in the bio-based sector at the regulatory level. So we are in the legislation sector. Thank you, Emad.
Thank you. I'm here to introduce my colleague, Nico Bertone, who is going through the regulatory tracker tool demo. Okay, we have Nico.
Hi, everyone.
Yeah, hello. So that is the regulatory tracker tool. I think is the one of the other tools that, as I mentioned in the first presentation, is kind of the tracking the policies and then how the policies related to the bio-based industry in textile, packaging, and fertilizer is going to be features. Of course, is under improvement, and then so always we had more data. It can be improved, but I think I will leave the floor to Nico to go through the tool.
Hi, everyone. Well, I will share my screen so you can see the. I hope you can see it.
Yes.
Can you?
Yes, now we can see it.
Okay, nice. Well, basically, the BIORADAR policy track tool tracks regulatory and standard documents, okay, across different relevant sources and industries. What do we mean with documents? Well, regulations, laws, proposed laws, standards, policy initiatives, directives, guidelines, also certifications. Okay, so the goal is to have a place for users interested in BioRadar related topics where they can find policies, well, policies or this kind of documents that fit their particular interest. So, for example, as you see, I have a text box to search anything here, and also some filters here. So if I, for example, type supply chain, I will receive some documents, some, in this case, policy initiatives, for example, and standards. There are a lot of them related with this supply chain topic. Well, in this case, it's easy to spot the relationship because you can read supply chain in the titles, but it is not only a full text search. This is a more technical detail, but in this case, the query is not only for full text, but it is also a semantic query because we are doing cosine similarity between the vectorized query and the stored embedding for those that can be interested in the technical details. I will do another test, I don't know, with circular economy, for example. And well, the same. We will receive some results of documents related, in this case, a lot of policy initiatives, makes sense, with circular economy. We can open one, and this is a small abstract of the whole document. Obviously, the title, some tags that we put in this document to relate with some industries, for example, some sectors, etc. And obviously, we have a link for the original document that in this case is from the European Union, where you can see the original PDF. Okay, what else? Well, we can also apply some of these filters. I can clear here and can go to the industry filter, for example, and I go for the packaging. And in this case, I will receive all the packaging industry related documents. Obviously, we can combine these filters. We can, inside the packaging filter, inside the packaging industry related documents, we can, for example, look for bioplastic. And we will receive the ones that are related with, in this case, you can read bio-based plastics, for example. And well, as you see, you can combine it with a lot of another filters like environmental impacts or document types. For example, if you are only interested in standards. We also have a more visual way to explore the document database if you want. That is this stats page. That, for example, in this case, the documents are organized by source in a more visual way. In case you are only interested with to the European Commission documents, for example, or by sectors, by industries, by environmental impacts. So, for example, if you are only interested in fertilizers related documents and you want to see how many of those documents are in the database, you can see it here. And also you can apply directly the filters clicking here, for example, to fertilizers, and you will see only the documents related with fertilizer industry. And what else? Also important to say, especially in 2026, that we have a mobile version that I can trigger like this, that I can try to zoom in. No, I cannot zoom in more, but I hope you see it. It is a mobile adapted version where the filters are in this foldable menu. And well, the whole app is responsive and everything, so you can do the same things you do with the desktop application, you know. So what else? This is an ongoing development. So we are planning to add a lot more things, like, for example, more sources. And also we are planning to add a conversational tool, like an AI agent that can help you navigate through the database and through your needs. And possibly in the future, even a user feature that you can log in, for example, and save the documents that you are interested in, just to personalize more your journey through the tracker tool database. And yeah, I think that's all. I don't know if you have any question.
Great. Thank you so much. Yeah. Great. It is really important. We are in the standardization, so in the voluntary standards, but it is just as important to know what is up with the legislation and how to deal with all of these different information and sources that come. It can be very difficult to find, especially maybe for an SME who has limited resources. So very interesting. Yeah. Now we do the voluntary part of the tracker tool for the regulation we have done, and now we have the standards with the Head of Innovation and Standardization from UNI, National Standardization Body, Elena. Welcome, Elena. She will talk about the Standardization Toolkit, which is supporting the alignment with standards and certification schemes who are existing in the field of bio-based.
Thank you. Good morning, everybody. Thanks for being here. We can move to the next. Oops, sorry. Okay, thank you. Great. I wasn't aware of it. Thank you. Right, so we are going to talk about what standardization did or is still doing in relation to BioRadar project. Well, it's a journey, actually. Standardization in our project, in this project, but in general, when dealing with European-funded project, it's a journey that starts with a state-of-the-art analysis. What's in standardization that can meet the need of the project in itself? So what is linked to standardization? What are the issues that standardization is addressing in relation to the project? And eventually, what is missing? Which is the more important part, actually. So the idea is to start, as I said, with a state-of-the-art analysis, which are the relevant standards for the project. And this is the standardization toolkit we developed somehow. Then, based on the analysis of what is already exists from the standardization point of view, we also did a kind of gap analysis. What is missing? So, what needs to be addressed in addition to what already exists? And in particular, which are the key aspects that we need to address or readdress in existing standards? This means that we are not only looking at what exists as it is, but what exists in the perspective that can be modified. As I always say, standards are not written in the stone, so they can be revised, modified according to the needs of the market and according to the needs of a research and innovation project, and this is the case. So in order to do this, we also had a number of liaison and link with standardization structure, in particular with ISO TC and SAN TC, dealing with the issue related to our project. So we established two official liaison with ISO, with two technical bodies in ISO. One well, is because it still exists, so it's living, is SANTC 323 for circular economy, and the other one is a specific subcommittee linked to ISO TC 207 dealing with environmental aspects, and the subcommittee is dealing with LCA, so the indicators and how to measure LCA. And of course, we use these standards and this connection to develop what are the different indicators that has been shown before for the BioRadar project. Finally, we managed to draft a SAN workshop agreement. It's a pre-standardization document. So we also developed this document, which will be the basis, which could be the basis for future standardization activities. And since there's a revision process it has just started on a specific standard, European standard, under the responsibility of SANTC 411. This standard might be improved by using the result of BioRadar project, by including some aspect which has been spotted thanks to the drafting of the pre-normative document, which will provide specific inputs for the revision process of this, which may provide specific inputs for the revision of this process, of this document, including also another document dealing with terminology, because there's also a revision process ongoing on terminology, which is quite crucial, actually, because not using the same terms and understanding the same meaning for the same terms might be a real problem when dealing with technical aspect and technical issue linked to bio-based product, which somehow is regulated but not fully regulated, and so we need to agree on the same languages. Going to the standardization toolkit, well, it's a toolkit which is based on a mapping of more than, well, actually, no, it's not more, it's 231 standards, actually, so the number is very specific. And we map them across different technical committees and across different keywords, actually. So the idea is to, the toolkit is available online, and we will provide the link by adding the link to the slides. It's not present at the moment, but we will add it so you can access the toolkit directly online. And it has been thought in order to support an easier way of searching standards, using keywords, for example, so using specific, there's a specific area where you can spot the different keywords taken from the different standards, and this will be helpful in order to identify the existing standards on a specific issue. And it also includes a number of, it's very intuitive because the interface is very easy to understand, and this provides also some information, direct link with the catalog, SAN, UNI, SAN, and ISO, so you have directly the link to the document. Which unfortunately we cannot provide for free because standards are sold, and so we can provide some information, and the information are described in the title and in the scope, so you can access the title and the scope of a standard, but not the full standard. Although we are thinking about some new way of providing access, at least in consultation to standards in the next future. Something is already going on, but at the moment our business model doesn't allow us to provide the standards for free because it's one of our incomes, actually. So, and I think it needs to be known, because otherwise it seems that we are a little bit schizophrenic in providing information from one side and asking for money from the other side. So, as I said, thanks to the standardization toolkit, you can access directly the catalogs and the documents. So it's an easy way to get to the right point where you can get the document. And finally, behind the state-of-the-art, the SEN workshop agreement, as I said, it's something that is already draft, and as I said, it can be shared with the relevant technical committees. I mentioned CEN/TC 411, but at the same time, it could be also used in other specific technical committees, maybe vertical for the single materials, for example, for textile, fertilizer, and so on. So we can also try to spread the content of the CWA also in other technical committees. Of course, the focus would be on CEN/TC 411, but it can also be shared with other CEN/TCs. And well, it's a collection of almost everything which has been done during the project in itself, and it will be included in one of the deliverable of the project. So it will be in any case available, and it's somehow a document which validates the different tools that has been developed and the different approaches and the different methodologies which BioRadar address in order to define the framework for the indicators, the environmental, circular, social, and economic. So it works on the different dimension of the sustainability, and it provides input and information also on the digital tools that has been developed thanks to BioRadar. And finally, it also includes some examples in order to show how the BioRadar approach has been can be translated into real life, let's say. So, and it has been translated into real life. So this is the overall description of what we did during the 3 years work in BioRadar. We did a lot of work thanks to the support of all the partners, because without the different partners we couldn't do it, because we somehow manage the process, but the technical content comes from all the other partners of BioRadar project. So thanks a lot to everybody, actually, really, for the great work we did in the CWA. Thanks. And, well, that's all.
Thank you so much, Elena. Yes, it was very interesting. As we said, the standards are not mandatory as legislation, but they are still a great tool for companies who want to have some guidelines or some guidance to understand what is out there and how it can be, they can apply and they can make their lives easier with documents that are already existing. And at the same time, as we said in the introduction, the goal of standardization is also to bring innovation to fruition for companies. So it is a way to bring the results of a research project into the real world and to try and put it in the market in a more accessible and widely available way. So it is a great part of these tools that we are seeing right now. The last group of tools that we have before we go for our lunch break, and also the last tools that the BioRadar project has developed are on implementation and replication. And here with us to tell us about these tools today is Stefania from Hamburg University of Applied Science. Quite self-explanatory. It is a university, but it's also an applied research institution. It is located in Hamburg, Germany. We are very happy to have you here, Stefania. She will tell us about two tools, which are the implementation scorecard, which support companies in adopting circular bio-based practices, and a replication facility, which accesses BioRadar tools and resources for replication.
Now, Thank you, everyone. Good morning from my side. Thank you, Chiara, for that very nice introduction. As Chiara said, I will be introducing the replication facility and the implementation scorecard that we developed for BioRadar. So the main goal of the replication facility was to harmonize and support the exploitation of all these nice results that the partners have been presenting already in the first hours of this event. And that it works as a platform that works to support the transfer of information with the relevant stakeholders that we have, especially the bio-based industry, policymakers, investors, researchers, and general consumers as well. The idea of this facility is to have it as a long-lasting knowledge platform and for cooperation as well. So the platform is going to be available for 5 years after the project closes now in June. So this is more or less the structure of the replication facility. I'm going to go into details in the following slides. But in general, we have an introductory section, the digital tools section with the solutions and the tools that we developed, the section dedicated to the massive open online course, and then some final additional resources that we included there as well. So in the introduction section of the facility, you will have a brief introduction of what you can expect from this facility, what you will learn, what kind of materials you will find. And we also included the first video that the NICE team from communication of the project developed, which explains very nicely what we are doing with the project, which sectors we are targeting, and so on. So it's a nice introduction for this facility. And then we have this section of our solutions. I'm not going to go into the details of the tools because it was clearly explained, I think, by our partners before, but I will talk specifically about the implementation scorecard. So the background for the creation of this implementation scorecard, we identified that there is a big gap for the SMEs in terms of assessing their sustainability performance. Even though they have an important representation both in numbers, employment power, and economic contribution to the European Union, they still have, they face lack of resources and sometimes lack of expertise in order to assess their performance. So this was our motivation to design this tool that helps to bridge this gap in a simple, structured, and valuable way so that the SMEs or startups in the bio-based sectors can use it. The concept behind this tool, it's an innovative and qualitative tool. It's a self-assessment tool as well. And it focuses basically on 4 dimensions. We used it to, we translated the broad SDG language into more concrete and sector-specific KPIs and questions where the companies can assess their maturity level, their maturity implementation of sustainability in 4 different dimensions: the environmental, social, economic, and circularity. So the idea that with this tool and with the results that they obtain with this tool is that they are able to identify the gaps and main opportunities for improvement of their performance. The methodology behind the implementation scorecard, first we started with the identification of relevant KPIs. We took the established frameworks that are existing already, like the GRI, ISO, and so on. And we identify the most important KPIs depending on relevance for each sector, actionability, transparency, and also simplicity of use. Based on these KPIs, we then developed sector-specific questionnaires, which I'm going to be showing you in a little bit. Then we design also the scoring system so that we can define in which situation the companies are. Then it comes the aggregation of these results, and then finally we provide them with a visual score and also some recommendations that they can implement in their operations to improve their performance. This is how the tool looks at the moment. It's a web-based app. So first we start with everyone choosing to which sector they belong. And then we have For each SDG, we developed 4 questions. Each of these questions addresses the circularity, the environmental performance, economic and social performance as well. And then they can choose, depending on their own assessment, their self-assessment, in which stage they are. So they can choose from 0, which is not applicable. This is an indicator that is not relevant for their operations, or number 5, in which it represents that they have already targets established, they have sustainability plan in place, and they are already achieving their targets. It would be a bit long for us to go through the implementation scorecard right now, so I'm just explaining it to you. As I said, for each of the SDGs, so for the 17 SDGs, we have a set of 4 questions. And then once you complete it, this is the result that you will obtain. The first result that you will obtain. So here you can see from the different colors how is your performance in terms of the economic, social, environmental, and circularity aspects for each of the SDGs. And then you also get this scoring depending on where you're standing. So for example, levels 1 and 2 are referring to that the company is aware of the issues that they are having and they are starting to making some plans to do some improvements. Scores number 3 and 4 represent they have already an action plan in place and they are working on reaching the targets. And the score number 5 is leading practices. So their sustainability plan is operational and they are reaching the targets that they set for themselves. Besides this general overview, you also get the results per the different dimensions. So for the economic, social, environmental, and circularity aspects, you get the score. And then after you receive these scores, then you can get different recommendations depending on the SDGs. These recommendations were co-created together with the companies, and they are based on best practices for each of the sectors that belong to the company. It's also important to tell that we co-created this tool with companies representing each of the sectors, SMEs and startups, and through the process they were able to tell us how useful the tool was for them, what kind of information that they can obtain, how we could improve it, and what is actually relevant for them. So the recommendations are not tailored for each company, because it would take much more data. It would require much more data for us to be able to do that, more specific. But these recommendations, as I said, are based on best practices, and it gives you a direction on which next steps you can take to improve your performance. Then we have the massive open online course. As I mentioned, I think you heard very interesting content that our partners have developed during their work and during the duration of this 3-year project. So the way we structured this massive open online course is based on a user-learner or learner journey. So depending on what kind of stakeholder you are, either if you're a researcher, you represent the industry, if you are from the policymakers or public authorities, or you are an end user of bio-based products, you can navigate the content of the massive open online course depending on the needs that you would have as a person. So basically, with these paths, we created these 4 different types of contents. The path number 1 then is dedicated to the general public and consumers. Path number 2, dedicated to public organizations and policymakers. Path number 3 is the industry and commerce. And path number 4 is for the researchers. Besides that, we have also the about and cooperation section, but I'm going to be talking about in a little bit. So here is a quick overview of the type of content that we have in the massive open online course. First, we start with a brief introduction, well, not so brief actually, but with relevant content, with basic terms and definitions in the bioeconomy that are useful to know for you to start and dive deeper into the more technical aspects. So we start with this course welcome and overview, presenting the objectives, what you are going to learn in these lessons. Then the specific definitions, benefits, and challenges when it comes to circularity and bioeconomy in general. And then an introduction to the bio-based transition indicators framework, which was very nicely presented by our partners as well. So we are introducing, besides this terminology, also what was the methodology, the metrics, and the indicators, how our partners did it during our project. Then we go a bit deeper into the technical perspective, covering everything that's related to the environmental aspects, environmental impact assessment, life cycle assessment, life cycle cost, eco cost, carbon removal potential, indirect land use, and so on. We then go also to the circularity aspects, everything related to the indicators that were developed and the methodologies that were used, also going to the end-of-life issues, and including as well the economic aspects that are relevant for circularity. Then, as part of the technical perspective, we also have a wide explanation on the digital monitoring tools that we have developed. So all of our solutions, how we develop them, what kind of methods were used behind it, and what kind of data you need and you would obtain from it. And that closes the technical perspective. Then we also have a section for the business perspective. This is also something that we worked in the project. So business models for the bio-based systems, cost, benefits, best practices and strategies. Then we also have economic and market analysis. What is the potential, opportunities, and some examples of successful businesses in the bio-based industry. And then we also cover the legal perspective, focusing mainly on the standardization in the bio-based systems that Elena very nicely presented before. To close the content of the MOOC, we prepared a case study, which is an interactive section with a fictional case where the learners can actually implement what they learn. So we give them a fictional company with a specific situation, and we ask them questions where they can interact a bit with the content and actually check how much they have learned from the content that we provided with the MOOC. So here is more or less the structure of our massive open online course. It would also take quite some time to go through each of the details, because each of the modules and sections that you see inside of there has quite some content. We have videos, we have infographics, reading materials, presentations, also some interactive activities that you can use. As you can see, most of the content is dedicated to the industry and commerce and to researchers and students, because this is mostly where the project was focusing, what we were targeting. But there's also very interesting material for the public organizations and policymakers, and for the general public and consumers as well. Everything has been we try to provide it in an easy language, easy to understand way, and also that people, our partners provided us with additional resources in case our learners want to go deeper into these kind of topics, that they can access additional resources where they can learn a bit more. In the additional resources that we have also in the replication facility, we have the About section, where we are providing you with the links to follow us on social media, to go to our website as well and discover a bit more. And then we also included a glossary of important terms in bioeconomy. And we have also a section dedicated as a file repository where you can find the public deliverables that have been developed for the project, and also the publications that we have provided that are most of them open access. So you can also check them there. Besides that, we created a cooperation section. In this part, we decided to go a bit in a different route that it normally is. Normally, this is managed as a forum section where people can have discussions and so on. But since what happens traditionally with the forums is that they get abandoned after the project finishes. So a good practice that we have identified was creating this curated database of key contacts in the bio-based sector. So we invested quite some efforts and time to identify the relevant actors, relevant stakeholders in the three bio-based sectors that we're targeting. So textiles, packaging, and fertilizers. And we map them by country, the type of organizations, and the most relevant information, so that the users that are accessing this database are able to quickly identify and reach out to the relevant organizations and networks that would be interesting for them to connect with. Last but not least, I think we can share on the chat now and the link to access and register to our replication facility. Also outside, you are going to find the flyers with an explanation of what you can find there again, what we are covering also in the massive open online course, and then you will have the QR code where you can access directly and register to our replication facility. That would be all from my side. I think I used a little bit less time that I needed, but if there are any questions or comments or something, I'm here to answer. Thank you very much.
Now we have a section that is the last one that is called Synergies in Action. Why have we called it Synergies? Because BioRadar is one of the many projects that has worked on bio-based solutions and on sustainability on in various ways. And of course, we have done great work, as we have seen in the morning, but this is not, we don't live in a vacuum, we don't operate in a vacuum. So it is great to have partnership and to try and have synergies with other European projects, as well as with other actors. In these synergies, we will specifically look at, in this first part, at LCA for Bio. LCA for Bio is another project, and it focuses on developing advanced life cycle assessment. So LCA, we have talked a lot about it. New methodologies to evaluate the environmental performance and circularity of bio-based systems. So very familiar to us from BioRadar. It provides standardized, precise tool tailored for bio-based products and supports industries in reducing pollution and improving sustainability. BioRadar project, as we have heard, has very similar goals. So there was a pioneering change and new methodologies and tools that came together from this partnership, and these two projects joined forces to tackle the challenges of addressing, monitoring, and improving the environmental and social impact of bio-based industrial system. We will have a few people from the LCA for Bio project joining us remotely. They are already connected. We have two people, maybe we have another one. We actually have three. So we have Lucia Garcia, Fabio Sporchia, and Anya connected right now. So I thank them for coming and joining us, and I will leave the floor to them.
Hi, thank you very much. Can you hear us?
Yes.
Yeah, great, thank you. So thank you for inviting us to present the project LCA for Bio in your final conference. I'm Lucia Garcia, and I'm the technical coordinator of the LCA for Bio project. Next slide, please. So we will start with a quick overview of the consortium and the project. Then we will go deeper into the circularity methodology we are harmonizing in the project. And afterwards, we will show the tool we are developing in LCA for Bio to assess circularity in bio-based systems. And we will have a short Q&A session and a farewell afterwards. So the LCA for Bio project is funded under the topic Environmental Sustainability and Circularity Criteria for Industrial Bio-Based Systems. It started in January 2024 and it will finish in December this year. It lasts for 36 months, is formed by 7 work packages and with a total budget of almost 3.5 million euros. And here we have a picture of our last General Assembly a month ago in Paris. So the coordinator is Contactica, which is a consultancy based in Spain. We have 2 offices, one in Madrid, where the headquarters are, another one in Pontevedra, which is in northwest Spain, where we have the Sustainability Center. Together with Contactica, we have 2 universities, Aalborg University in Denmark, that we have here Fabio and Anya from there that will present today. The NTNU in Norway, research centers such as INSA Toulouse in France, the Luxembourg Institute of Science and Technology, CESEFOR in Spain, also SME, as Contactica is an SME, together with GoUp Business Incubator in Bulgaria. Then we have from the industry side, Sonairo from Portugal, and Cluster Bioeconomy for Change in France. And as a certification body, we have PFC Spain. So the main objective of the project, like you introduced very well before, is to harmonize assessment methodologies to properly evaluate impacts and circularity in bio-based systems. So that can be applied in certification schemes, enabling the international trade of this type of products. And also we are developing and harmonizing new prospective life cycle assessment methodologies for low TRL bio-based systems. So to reach this main objective of the project, first, we are harmonizing and improving the methodology to assess sustainability and circularity related to both high and low TRL bio-based systems, starting with integrating time-dependent factors into the assessment framework. This is called the dynamic carbon footprint. Also identifying and selecting optimal impact assessment methods for evaluating bio-based systems, impacts in bio-based systems. Also improvement of circularity assessment methodology for bio-based systems to identify specific circular strategies. Also including analysis of the socioeconomic substitution effect and also selecting best socioeconomic indicators to assess impacts on bio-based systems, and including prospective LCA with integrated assessment models, in this case to assess impacts on low TRL bio-based systems. After harmonizing the methodologies, we are creating a set of tools to ensure the applicability of the methodologies previously developed. So for high TRL, we are developing the Dynamic Inventory Assessment Tool, Dynamic Toxicity Tool, Circularity Assessment Tool, Dynamic Carbon Footprint Tool, and Life Cycle Costing Tool, and the Job Creation Potential Tool, the latter for the social LCA. And for low TRL, we are also developing the prospective LCA tool. And then the last step to reach the main objective of the project is to include the methodology in the PFC standard to allow certification of products and international trade. In this case, this standard will be included in the core standard chain of custody of forest and tree based products requirements. So that will be it, and I will give the floor to my colleague Anya. Thank you.
Thank you, Lucia. I hope you can also hear me. I would like to introduce the work we did in the LCA for Bio project on identifying indicators which can be used to assess circularity of bio-based products. Yeah, Fabio, thank you. You could say that the aim and objective of this task in the project was to develop a set of circularity indicator and also a guidance document which could be used to assess the circularity of bio-based products. The approach we took was that we firstly started to identify these circularity strategies that can be applied to bio-based systems. Then we identified macro and micro circularity indicators that could be used or applied on bio-based systems. and addressing these different strategies we had identified. And then we did a categorization, scoring, and selection of the best fitted indicators. Yeah. Thank you. Next. Yeah. The approach we took for achieving this objective and aim was that we did a critical review of circularity indicators in the academic literature, and we supplemented this with some of the more recent standards on circularity developed by ISO, and then also two projects, EU-funded project also working on bio-based systems, the Calimero project and the Orienting project. Based on the identification, we did a scoring of the indicators, and we used the scoring to select the indicators going into the sustainability assessment. First, we identified these circularity strategies and also these, you could say, related sub-strategies which are relevant for bio-based systems. And these sub-strategies, they identify more actionable circularity strategies covered by these main circularity strategies. And these are all strategies that can be used, you could say, if we want to make our bio-based system more circular. And therefore, it's also what we can use if we actually want to measure if the bio-based systems are circular. And this work is you say, developed based on some previous work by colleagues from Wageningen University. And it covered strategies such as reduce reliance on fossil fuels, increase the share of renewable resources, regenerate strategies, circulate strategies, and also strategies focus on extending the high quality use of biomass, and strategies on economic and social viability, and also indicators that covers more than one strategy, like multiple circularity strategies. Yeah. This review showed that there is a very high diversity in the indicators which are used to assess circularity of bio-based system. In the 39 studies that we included in the review, 143 different indicators were identified. And the majority of these indicators were only used once or in one study. This indicates that there are very few indicators which has really gained ground and are widely applied across a number of studies. There are a few indicators who are used more often, and that's you could say traditional indicators such as recycling rates and resource productivity indicators, but also methods such as environmental life cycle costing, LCA, and material flow analysis. Yeah. The review also revealed that there's a big variation in how well these circularity strategies are covered by existing indicators. And this, you could say, difference is also evident across the different analytical level we examined, so the micro, meso, and macro level. What we saw was that the least developed circularity strategies when it comes to indicators are strategies such as social quality, and also this about how we actually measure how we optimize the utility of the products. Whereas the most well-developed circularity strategies in terms of indicators were strategies such as resource efficiency, regenerate strategies, and also recirculate strategies. What we also saw is that when we are considering circularity strategies such as maximizing the utility of the product, then this also extends beyond the use of indicators, but also requires that we are modeling multifunctionalities of systems. Yeah, thank you. Next, Fabio, thank you. After we had done the identification of the indicators, we did a categorization according to the strategies, and then a selection of the indicators. Here we developed 6 selection criteria covering stakeholder acceptance, applicability and complexity, transparency, scientific robustness, completeness, and also compatibility with life cycle approaches for it to fit into the LCA for Bio project, of course. And beneath these also 12 sub-strategies. Then the selection process in itself was an iterative process involving the product partners, where we did a scoring of the different indicators based on the defined criteria, and then the scoring was reviewed by the remaining partners, which were mainly LCA experts and circularity experts. And scorings were resolved during a meeting. Yeah, next. Yeah. Based on this scoring, we developed 3 indicator sets, 2 generic indicator sets, which can be used widely for different types of products within bio-based systems, and then a sector-specific indicator set for the wood sector. In addition to these indicator set, we also developed this procedure for how to do the sustainability assessment, which was inspired by also the ISO standard for circular economy. Yeah. In conclusion, due to the very high, what we found is a very high diversity in the indicators used, to assess circularity for bio-based systems, we need more focus on standardization and alignment of indicators going forward. But there is also a need to develop specific indicators that are covering some of these circularity strategies, which are not well covered yet, and also to have more sector-specific circularity indicators. Yeah. And now I will give the floor to Fabio, who will present the work that followed after this work, and that is developing into this indicator sets into a circularity tool. So Fabio.
Yeah, thank you very much, Anja. So yeah, as you just anticipated now, I'm gonna show you what's the more practical result of the work that Anja just presented, and this resulted in sorry, it's a little bit delayed, in a circularity tool that works whose objective is to guide a selection process to identify what's the ideally the best indicator that fits the need of the user. And it works like a selection process in a nested way. So we have 4 levels of selection. So ideally in 4 clicks, you find the indicator that most or suits the best for your case, for the case of the user. So here are some of the main features of the tool. It's based on Excel. It's very light, so it has a lower size than 1 megabyte. It has definitions. It shows formulas. It has no macros, so no security issues. It can be shared easily, and the cells are blocked, so there's no way to mess up, let's say, the calculation spreadsheet. And it has a common structure with a common color code across the different sheets, as I will show you shortly after. So how does it look like? Here I have some screenshots from the tool, and then I will show you how it works live. But just to have an idea first, this is what the selection page looks like. As you can see at the top, there are 3 simple instructions, and the important thing is to follow them strictly, hopefully. So just to have an example, if our supply chain, if the system that we are analyzing is about wood, is within the wood sector, then we can just select the option of the top slicer, and then we will see the second slicer will first of all, there will be a filter that's important to notice for the functioning. That will be activated. I'll get back to that. Second, the second slider right below the first one will show up as only one option is feasible because it's wood, and the other two are grayed out, so cannot be selected. So if we select the only available one, we can get to the following slider, which can guide through the selection of different circular economy strategies. And if we select, for instance, ensure generation of natural system, then we also get the other filters, and we scroll down. This is just the bottom half of the sheet. We can see that we have 4 available sub-strategies, and which are the one where you can see the 4 arrows at the bottom. And so if we select one among them based on our needs, then we can, for instance, if we select maintaining carbon cycles as a potential sub-strategy of interest, then we have the last slider with all the indicators, and we can see that the only available indicator here is the, for instance, carbon stock and CO2 absorption. And right next to the last slide, there is a huge yellow cell that should be evident enough that if the user clicks on that, redirects you directly to the calculation page that is looking like this one. So at the top we have a recap of the selection that we carried out to get to identify this as a suitable indicator. So you can see basically the 4 sliders and the last one that is the indicator. You have the reference here, and there's also a list of references that I'll show you later. Then you have color code at the right top right side of the sheet, where everything is explained in terms of colors. And then you have, for instance, in this case, the input data should be inserted in this yellow cells down here. And you can see J, all the symbols are explained in a plain way, no need to be an expert. And then you have, for instance, some auxiliary formula that are just needed to have a step-by-step breakdown of the whole calculation. So everything is explicit, nothing is hidden. And the red ones are not necessary to be used or modified. And finally, we have the indicator that is what the user is going to be most interested about. So now I can show you how it works live. And so this is the Excel file. I hope this is, yeah, maybe I can zoom in a little bit. This is the landing page, but just to recap all the information. But I just want to go to the Finder directly, and I will zoom in a little. Yeah, this is exactly what I showed you before, with just one little detail that we have revised a little bit the definitions and the names of the strategies and sub-strategies, just to make them a little bit more, a little bit less ambiguous maybe, and more straight to the point. But everything is documented. Anyway, the definitions should also clarify what we mean with the names that we have given to the strategies. So, for instance, again, if this time we are not dealing with wood, and maybe we are working with a microscale system, and for instance, we are interested in resource efficiency and waste management, just an example. And if we look at what kind of sub-strategy the resource efficiency and waste management strategy has, we can see that there are two available, and maybe we're interested in resource efficiency. So we select this, and we can see that we have one potential strategy. So we select this, and we then click to the calculation. To the link to the calculation page, and now we have landed to the actual calculation sheet, and we can fill up the input fields that are the yellow ones. So if we have, I don't know, 15 kilograms here, and we have 15 kilograms of primary feedstock, 1 kilogram of target, 2 kilograms of co-products, and maybe, I don't know, 3 kilograms of material recovered or recycled from a waste product. This is just an example. I'm of course making things up here just to show that everything gets calculated. The formula is visible, nothing is hidden. So this is pretty much immediate, straightforward for anyone that has no expertise, even in dealing with a complex calculation or advanced Excel functions, no macros and nothing. And yes, this is the tool. So now I leave the floor to Lucia. I'll stop sharing. So now you can share, I think, right?
Can you see my screen now?
Yes.
I'm sharing the last part of the presentation. Great, thank you. So, well, this was a very short workshop we did today with you, but in the LCA4Bio project, we are doing a series of workshops to show the methodology, and also at the end of the project, we will have training workshops. So if you would like to attend, you can register in our website, complete the form, and we will invite you to the next series of workshops. The next one will be the 5th of June on social life cycle assessment, especially the job creation potential. And on the 12th of June, we will be doing the workshop on prospective LCA. So if you would like to join, if you would like to be updated on the project and on our work, please join the community. And thank you very much for inviting us today, and see you in the next workshop.